Okay, ladies and gentlemen, lesson 43 is on simplifying rational expressions. So first we are going to take a look at some rational expressions, and we need to determine which values for the rational expressions is undefined. Now remember, undefined deals with 0 in our denominator. Okay, so we need to look at each of these and ask ourselves, what can what would x have to be to make the denominator 0? So easy way to do this is just set your denominator equal to 0 and solve for the variable. So we're going to divide both sides by 5. So x equals 0. Okay, we're going to set our denominator to 0. We subtract 8 to both sides. So x equals negative 8. Because if I plug negative 8 back in here, negative 8 plus 8, this equals 0. Okay, and we can't divide by 0. And our last one like this, 6x plus or minus 42 equals 0. So we add 42 to both sides. So 6x equals 42. So we divide each side by 6. So x cannot equal 7. So that's the thing, and we should put in a not equals, because if x equals those, then we get 0. So we say x can't equal those values. Okay, so now we're going to actually have to simplify the rational expression and then also determine the undefined values. Okay, so to simplify them, first we need to see if there's anything we can factor out. Okay, so if we look just at the numerator in D, we have 7x minus 27. And we ask ourselves, is there anything I can divide out of both 7 and 27? There's not a number that divides into both of those. So we can't factor that out. 7, 27, and 5, none of those will simplify. So this is as low as you can simplify it. And so now we just have our denominator. We set to x equal to 0, divide by 5. So x cannot equal 0. And this is the simplified expression. Okay, so let's look at E. I'm going to look at the numerator first. So I have 3x squared minus 3x, and I ask myself, is there anything I can divide out of both of those? Well, I can divide a 3 out of both of those, and I can take an x out. So we're factoring that out. That's the greatest common factor. And what's left is x minus 1. Now we're going to do the same thing for the denominator. 9 and 15. Well, 9 I know breaks into 3 and 3, and 15 breaks into 3 and 5. So I can divide a 3 out of both of those. I can also take an x out of both of those. So I'm left with 3x plus 5. So the 3x's are going to cancel, and I just have 3x plus 5 on the denominator. So my simplified version looks like this. And now I need to set my 3x plus 5 equal to 0 and solve for what x cannot equal. Because if x equals negative 5/3, my denominator will turn into 0. Okay, let's do the same thing in f. All right, so 4x plus 28, I can take a 4 out of both of those. No variables. And I'm left with x plus 7 on the top. In my denominator, I can take out a 3 and an x. I'm left with x plus 7. This time, the stuff in the parentheses is what cancels. So my simplified expression is 4 divided by 3x. So we set 3x equal to 0 to figure out what x cannot equal. So both of these are answers to this problem. All right, so simplify. This has pi in it. Okay, so looking at my numerator, I can take a 2, a pi, and an r out of all those terms in the top. So I'm left with an h and an r. In the denominator, I have pi. R squared is the same thing as r times r. So I can cancel my pi's, I can cancel the r's. So I have 2h plus r left in the parentheses, and I have rh in the denominator. Now, I cannot simplify these because right here, these are added together, and so you can't separate them. So I have a 2h plus r over rh. And let's come up with what my variables. If I have r times h in the bottom, r cannot equal 0, and h cannot equal 0. There you have it.